Hello, welcome to part 2 of piecewise functions. In our previous video, we looked at how to evaluate a piecewise function. Today we're going to be looking at how to graph a piecewise function. As a reminder, a piecewise function is really when you have two equations that are placed on the same graph. So again, like we have here, we have two equations. When the first equation gets drawn, there's our first equation. The first equation has a start point, or a stop point rather. Once that first equation ends, that is going to be where the next equation picks up. And that is going to be those two equations that are going to be drawn. And that is, generally speaking, how we're going to graph piecewise functions. Now, how do you do that practically? Well, there's a couple of ways, and I think the easiest way to do them is to go to a table of values. Now, I realize this might not be the easiest, not necessarily the quickest method to do it, but it is a way to do it. So here we go. Here's our piecewise function. What I'm going to do is I'm going to maybe scroll out just a little bit, make it so we can see everything nice and neatly. Draw. And that. Alright, so if I wanted to graph or evaluate this piecewise function, I'm going to start taking in my x values, and I'm going to plug them into my equation to graph. And then after I got my table of values, I'm then going to go to the graph and plot. Now, the one thing we need to be aware of is as we're testing our x values in, are we testing it into the correct equation? So let's just start with negative 4. When x is negative 4, which interval does negative 4 fall into? Is negative 4 less than negative 1, or is it greater than equal to negative 1? Well, negative 4 falls into that first interval. It is less than negative 1, so I'm going to evaluate it as negative 2 times negative 4 minus 2. So I put that negative 4 into that first interval, and I'm going to evaluate. I'm going to repeat. Negative 3. Negative 3 falls into which of the intervals? Is it less than negative 1, or is it greater or equal to negative 1? It's still less than negative 1, so my equation, negative 2, negative 3, minus 2. Evaluate. Do it again with negative 2, negative 2, negative 2, minus 2 is 2. Now when we come to the value of negative 1, let's see which point, well, something interesting happens. Negative 1 is where those two equations switch. So these two equations sort of switch at negative 1. This equation stops at negative 1. This equation starts at negative 1. Negative 1 is that switching point. So I'm actually going to graph, or I'm going to calculate that value at negative 1 in both equations. And you'll see why in just a minute. So if I put negative 1 into that first equation, negative 2, negative 1 minus 2, I get a 0. And if I put it into that second equation, negative 1 plus 3, I get a positive 2. So I'm just going to say I have two separate answers that I'm going to have to deal with here in a second. And you'll see what I mean in just a minute. If I continue on, plugging in my points, 0 goes into which interval? That second one. 0 plus 3, 3. Plug in 1. 1 plus 3 is 4. 2 plus 3 is 5. So now, I'm going to graph my points. My first point, negative 4, 6. Negative 4, 6. My second point, negative 3, 4. Negative 3, 4. Third point, negative 2, 2. Negative 2, 2. Now, again, this was that break point. This was that break point at the negative 1. Now we're going to go back and we're going to think about when we were graphing inequalities a couple of lessons ago. And we're going to go back to the idea of an open or a closed circle. And hopefully you remember if it was a less than or a greater than sign, we were using an open circle or an open dot. And if it had the equal to portion, it was a closed dot. We're going to repeat that process again with our piecewise functions. So we're going to use the point negative 1, 0. And because that was just a less than, that's going to be an open dot at negative 1, 0. Negative 1, 0 gets a open dot. And I'll switch colors. Then negative 1, 2 is going to get the closed dot. So now I'm just going to continue graphing my points because now we're on that second equation. 0, 3, 1, 4, 2, 5. And if I were to draw these lines, line 1, line 2. So our first equation, negative 2x minus 2, is going to be this line that goes all the way. We're going to graph it all the way up to when x is negative 1. So we graph this line all the way up to when x was negative 1. And then that's where that open circle was. The second equation, x plus 3, we weren't going to start that equation. That equation didn't start getting grafted until negative 1. So over here on the left side, it didn't exist. Once negative 1 happened, now those are the points. So there is the graph. These are new. So let us try a couple of more. Let us show a few more techniques that we can do, maybe something to help you along. So let's look at this problem here on the left. Let's zoom it in a little bit. Now I don't know about you, but I have a calculator and I would ideally like to use my calculator. So I'm going to go ahead and I'm going to pull up my calculator so we can use it. Because if we have the tools, might as well use the tools. We're going to go in and we're going to graph the two equations, and then with our equations, we're going to use the table of values. The table of values is a really useful tool for us. It's a really useful tool. So let us, if I can find my calculator. Here it is. Let's bring this on over so we can see it. So I'm going to graph that first equation, x plus 2. I'm going to go clear out what I have in there from old work. I'm going to go x plus 2. Now, I really don't care so much about what the graph looks like. I really want the table of values. So to get the table of values, it is right above the graph button. I am going to hit second and then graph. And when I do that, I get my values. When x is 0, y, x is 0, or x is 1, y. I get all these, and I can use the up and down arrow to see everything that I want. So now, for this problem, we're going to look at real quick. For this problem, it says I'm going to use the first equation for all the points when x is less than 0. So less than 0 means some negative numbers. So I'm just going to scroll up and get some negative x values in my table of values. And I got some points, negative 6, 4, negative 5, 3, negative 4, 2, negative 3, 1. And I'm going to plot all these points up until the point when x is 0. And because in this top equation happens to be a less than, it's not equal to, that's where I'm going to put the open circle. So I would say right now, if you want, go ahead and pause the video so you can copy down those points. I'm going to do that myself. I'm going to get them graphed, and I'll see you in just a second. So let's see, negative 6, 4, negative 5, well, mistakes were made on my part because I can't read numbers right. Try that one more time. Negative 6, negative 4, negative 5. Here we go. And then at the 0, I have an open circle. Now, that 0 is where the transition from equation 1 to equation 2 is going to happen. So now at that 0, that's where I'm going to switch to my other equation. And so I'm going to go ahead and again just graph my next equation. Grab my calculator. Go to y equals, type in my next equation, 2x minus 1. Again, second and graph gets the table of values. And now those are the points I'm going to graph. But this time I'm going to start at 0. And go on. I'm doing numbers greater than 0. And at the 0, because it's an equal to, it gets the closed circle. So again, You can pause the video for those points. I'm going to move this aside so I can graph it myself. So we're going 0, -1. Plotting my points. Now I can draw my lines, create my lines, and there would be my piecewise function using the table of values. Again, second graph gets the table of values. I just plot them, and when one equation ends, that's where the other one picks on up. So table of values is a really easy way to do it. Table of values are a really nice way to graph overall. So again, second equation here, I would say if you want, go ahead and pause the video, give this problem a try on your own. I'm going to go ahead and do it for me real quick. I'm going to use the table of values. I'm going to go ahead and graph the first one. Clear it out. 2x plus 2. I get those table of values. I can now plot my points. Let's make it so we can see both at the same time. That'd be nice. Put that over there. That works much better. We can see them both at the same time now. So now my transition from one equation to the other is going to happen at that +1. So again, I'm going to plot the first equation when we're less than 1. So here, scroll down just a little bit. So we'll go -4, -6. -1, 0, 0, 2. And again, that transition was happening at +1. And so at +1, y value is 4 is an open circle. At this point, let's go check out the other equation. The other equation is x minus 2. Again, I'm just going to graph x minus 2. Table of values. Now, notice something here. Neither of these equations has that equal to portion, so they're both going to be open circles. They're both going to be open circles, and that's perfectly fine. That will happen from time to time. But again, we can go and start at +1 when x is +1, and we can give these a try. So x is +1, the y value is -1, +1, -1. I said open circle there. That was a mistake. Open circle there. And then we can just plot our points. Our graph, our piecewise function is now graphed. Table of values. They're really helpful when graphing piecewise functions. Graph the first one. Note where your equation starts and stops. Note if it's going to be an opened or a closed circle. Hope you have a wonderful day. Take care, be well, and tomorrow I'll look forward to talking about step functions. Bye-bye.